Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Hussein, number matrix BN2710057. I'm from section 2 for engineering lab 1. My topic is experiment 5, hardenability test Jominy and Quench. For the theory, all factors may influence the depth of which a piece hardens are maintained constant. A typical hardenability curve is presented in the figure. The quenched end is cooled rapidly and exhibits the maximum hardness. 100% martensite is the product at this position. CCT diagram for a eutectoid iron carbon alloy onto which are superimposed the cooling curves at 4 Jominy position and corresponding microstructures that results for each. For the results, specimens used in this project was a plain carbon steel. From the graph, we can see that the fastest cooling rate, which located closest to quenched end, gives the highest hardness when having Rockwell hardness test. When the test continue, with the increasing distance from the quench end and decreasing number of cooling rate, the hardness value is getting lower. For the observation from the results we shown before, different cooling rate give different hardness when tested. The reason behind this occurrence can be found when we refer to the microstructure formation of the specimen graph. From the hardness versus distance graph, different cooling rate give different formations along the specimen. When the specimen is heated until certain temperature, the microstructure of the material is fully austenite. When quenching begin to take place, the temperature starts to drop and until certain temperature, it will transform into martensite, which has the highest hardness of formation. So for the conclusion is, the higher hardenability, the deeper the information of martensite from its surface. As for its hardness, it forms the hardest part at the fastest cooling rate location, which is at the tip of the quench end. To sum up, the cooling rate affects the hardenability of the material due to the different microstructure from when the material experiences quenching process. That's all for me. Thank you.